Such given an array of integers nums which is sorted in ascending order and an integer target, write a function to such target in nums. If target exists, then return the index, otherwise return -1. You must write an algorithm with log or, of log n runtime. So this is the first example. We have nums, and we have this array and the target and the output. Um, the output, the target is 7. So and we get the output of 4 because the target is 9 and the output is 4 because we our index of 9 is at 4, 0, 1, 2, 3, 4. Uh, uh, Example 2, our target is 2, uh, and we don't have 2 on this array, so we have to display the output. This, like it says over here, -1. So that's it for this problem. So let's get into it. Let's make our two important pointers. Uh, Left pointer and our right pointer equals to, let's give our left pointer the index of 0, and the right pointer is the maximum value in the array. So we'll do that by doing a len of nums, and then since we have the len of this array is 1, 2, 3, 4, 5, 6, 6 and 6. So 0, 1, 2, 3, 4, 5 with the index of 5. So the goal is to give it the index number. So index of 5. And make this multi-line comment so that we can see what our goal is to achieve in this. These are the main things that we have to focus on being able to solve. Let's make a while loop while our left pointer is less than or equal to our right pointer. Less than or left pointer is less than or equal to our right pointer. Loop. Okay. So now what we're going to do is to check for the midpoint. So let's define our midpoint. Our midpoint is equals to our midpoint is equals to our left pointer plus our right pointer floor divided by 2 for division sign. Okay. So what this does is add our left pointer and our right pointer and divides it by 2 and round down to the closest number. So in this case 0 is the left pointer, plus 5. 0 plus 5 is 5. With this sign for floor division sign by 2 will give you 2 because it will round down to the closest number, whole number, integer. And that's our midpoint value. So in this case 0 plus 5 is 5. 0 plus 5 is 5, and divided by 4 divided by 2 is 2. So 0, 1, 2. So this is our new midpoint value in this case for the first loop. So if our nums midpoint, the nums midpoint value midpoint value is equals to the target value, then just give us our midpoint index. Return midpoint index. That's the index to the midpoint. Let's make our second. So the midpoint over here is not equal to the target number. So let's make a new condition. Conditions. Okay. So if nums, let me copy and paste this quickly. If nums is less than target, then let's move our left pointer equals to our midpoint plus 1. So for the first iteration, I mean for the since we don't have it first loop, since we don't have it over here, now this will be our new left pointer over here. So let's make our else loop for the left pointer, because there's only one left pointer, right, for right pointer equals to midpoint minus 1, because the right pointer will move this way if it needs to be moved. Case if there is no value matching target value, return -1. So the first loop for this one, I think this is all that we need. So if left is less than or equal to the right pointer, in this case this is the left and this is the right, and midpoint is equals to the left plus right. So for 0 and 5 indexes, 0 plus 5 is 5 divided by 4 divided by 2, that would be a 2. So 0 index, the midpoint is now 0, 1. The midpoint is 0, 1, 2. So this is the midpoint now. So if the midpoint is equals to the target, there's no target over here. I mean, this is the target, but this is not the target value. If midpoint is equals to the target value, return midpoint. So this one does not apply. So else if midpoint is less than the target. So if it's less than the target, midpoint left pointer plus 1. Left pointer plus 1 is left pointer plus 1. So left pointer. So I mean midpoint plus 1. So sorry. So we add this. Now move this to the. So now this is our left pointer, and this is still our right pointer. So now let's go start the loop again for the second time. Now if left pointer is still less than this, left pointer is still less than the right pointer, and the midpoint now is at the index of 0, index of 0, 1, 2, 3, 0, 1, 2, 3, 3. plus 5. 3 plus 5. The right point is at 5. That's 8. 8 for divided by 2 is for 4. So now our midpoint is should be at 4. 0, 1, 2, 3, 4. So now this our index of 4 matches our target, and this applies. The midpoint value is now equals to the target, and that's the return statement. So let's see if it works. Midpoint, yeah. This one should work. Or right output right pointer equals to left pointer target less than target, else this one worked, and this one there's a mistake that needs to be fixed. Return midpoint. Return the midpoint. Midpoint equals to left pointer. Oops. It should be a 1. It should be a 1 because 0, 1, 2, 3, 4, 5, 6. No, 0, 1, 2, 3, 4, 5, 5. So and the length will be 6 because 1, 2, 3, 4, 5, 6. So we just minus the length, num's length minus 1. This is how we get a 5. So our index numbers. So and that's it for this problem.